Okay, I'm Dr. Cobb. This is Ticks. This is our STEM Sunday session. And we're getting ready for the eclipse. You can see it on my t-shirt here, the Texas Eclipse Club. So we're giving a series of lectures and presentations on how to use telescopes and how to view the eclipse and be ready, prepared for it. And then after that, we will go into more NASA projects to include Armistice 2. So today, as I said, it's a STEM program, and STEM is a little bit vague. People are kind of defining it the way they want, but STEM is pretty well thought out. STEM was done when I was in school many years ago, but it wasn't taught STEM. So it's what the difference between what you call hands-on learning, on-the-job learning, whatever you want to call it, and curriculum learning. The way I explain it, if you have a flat tire, if you go to a school, they'll teach you, book chapter 1, how to start the car. Chapter 2, how to listen to the radio. Chapter 3, whatever. By chapter 7, you might get to how to change the tire. That's curriculum. They've got to fill time and dates and so on. So it's week 1, week 2, week 3. And that's not the way life goes. If you look at the landing on the moon, it was almost a comedy of errors. But everybody thinks we've accomplished most of our goals. There's human error, there's computer error, and there were some other errors that caused problems. But everybody seems happy with it, and they're going to go on with it 2 weeks from now. So STEM is science, technology, engineering, and math. So you find the hardcore STEM teachers will always make sure that the presentation includes all three. Whereas in a curriculum, you would take mathematics, then you would take physics, then you would take something else as separate courses, separate times, maybe different years. Whereas in STEM, they are combined. And math seems to be at the end of it. So basically, what we're going to do today, and a lot of people do this, even teaching music, they have the student learn a song from the end of it rather than from the front. If they learn it from the front, sometimes they never make it to the end. So they start at the end. Okay. So anyway, let's throw in a little bit of math to start with. So most of this we've gone over in the past, and Elise has gone over several of them with us. So I just put up there first, and this is middle school math. So it doesn't hurt for you to be exposed to it, and anybody in middle school for sure graduate should be aware of this. This is part of the criteria. So a squared plus b squared equals c squared. Now what I try to do is simplify this so you have a lot of handles to put in the back of your brain, and with that handle you can pull a lot of wagon with it. So it pulls a big load. Okay? So now draw a right triangle. Okay, now what we're going to work with is what she's drawing is various sized triangles. But the one that's used mostly for teaching and actually in life by anybody, somebody who's going to fly drones, a carpenter, is called the 3, 4, 5. So plug 3 into A. Now get that in your head. It has to be a right triangle. So the first thing you have to learn in life is what is a right triangle. That's very important. If you look around this room or a house, you'll find right triangles all over the place. So that's the most important triangle you've got to know. A 90-degree triangle, just straight up, and especially for astronomy. Okay, so now make A3, up here, 3, 4, 3 plus 4. Okay.
Wait, no. Okay, 3 plus
do the equation. 5. 3 squared plus 4 squared equals 25. Okay, have you had squares yet in math? 2 times 2 equals 4?
No, they don't do square roots in 5th grade.
No.
Yeah.
I'm trying to think when that should come. Definitely have to come next year.
Yeah, I think they do it in 6th grade.
Okay, a square is you just double something. If I have $10, I want to double it, I want $20. If I have a nickel, I want to double it, I have 10 cents. You just double something. So 2 times 2 is 4. 3 times 3 is 9. 5 times 5 is 25. So that's your basic equation. Okay? That thing does an awful lot for you in math. Okay? Now draw a line under there. Wait, I'm sorry. I've got one more thing. There's one more caveat here that helps before we turn the page up. Draw that triangle again. The same triangle. Okay, now, I'm sorry, draw it lower, I'm sorry, a bigger one. Okay, now, try to get this in your head now. She's going to draw a circle. So these, in 3D printing, when you get to 3D printing, these are what you call primitive figures. A circle, a triangle, a rectangle. You get more complicated with parallelogram and so on, but they're called primitive. So it's the first things you start to use in math and in physics and so on. So now draw a circle that touches each of those things. No, inside that touches. Wait, let me show you. It's got to touch here and here and here.
Got it? That works.
Okay. So if you look at that very close now, here, you'll see that this is equal to that, that's equal to that, that's equal to that. So if you're outside putting up an antenna and putting up a guy wire, or if you're on a boat, you want to put up a sail, this is where this kind of math comes in. So if you got it in your head, you just think about this, you start putting there. Put some other numbers in there. If your antenna has to be 40 foot high, then you make it 40 foot and solve your equation. Everybody done that? So this is equal 1, 1, 1, 1, 1, 1. Just ones. No, I'm sorry. 1 line, this is 1, that's 1, this is 1, that's 1, that's 1. So now you actually have the equation for a circle too.
So each side's 1.
So you can
They're
get the
equal.
lengths, you can get the volumes of that circle. Okay.
I'm so confused.
Any questions so far? Okay. I'll turn the page. Now the second part of this mathematics, and I understand this is pretty tough stuff.
Yeah.
And especially if you're not up on math. But as we go forward, after a period of time, you'll find out that you can see what she's learned, but they're doing it over and over. Okay, now draw the top half of the paper, a coordinate, x, y. Now, we've done this before. Yeah, I'm not sure you can take that. She should be at the point where.
Yeah.
Okay.
He's doing good.
And this is your x and your y axis. Now for 3D printing, your 0 or your z will come out of the page towards you or go that way, which makes it 3-dimensional. This is 2-dimensional. Okay? So now draw a circle.
We're getting ready to cover this.
Anywhere in here.
We're getting ready to cover this after spring break.
This then, once we get through with this, you almost have a course of trigonometry already done. So anyway, put on the start. This is called the circle of units.
Yep.
So I just showed you. We're going to start with units of one. One. Okay? So this is going to become one. Okay? And then we're going to go up here, down, and around, and you can put degrees. 0, 90,
180.
180, 360.
I thought you were saying no.
270, isn't it?
Anyway,
360.
No, because 360 was back.
okay, now what we're going to do is put that triangle we just learned inside here. So we'll put here 5, 30, 60, 45. Anyway, you're running out. That's okay. All we're trying to do is get a concept. Okay. Now, go on in here. And what do you got? You got that triangle. Drop the line down. You can see she dropped the line down. So this confused me for years till I learned this. This is trigonometry. This is the whole world. So basically, this is your angle. Put your angle there. An angle is like this. Okay? This is 90 degrees. That's 45, halfway. So, there's another unit that we're not going to use, get into, called a radian. So, a radian is a little bit more complicated in that it uses, but it's a little bit more accurate in that it uses pi. So, we're just going to use the basics that we talked about there, the angle, and so on. So, basically, this here, go up here. What do you think now? Okay, make just one in here.
One what?
Yeah. Just one. Yeah. Okay. Now. Okay, let's start there at the start. That's 0. Put 0 there. We're going to talk about units of 1 now. So put 0 here. Then up here is plus 1. Okay. That would be minus 1. Okay, so just leave it go
No,
here
minus,
for
no,
now.
minus 1.
So anyway, as you go around that circle, some things are going to happen. This is where the universe is so amazing. If you think about how all this math and physics just happened to be, or somebody had to do it. I don't subscribe to this happened to be. It's too advanced, the knowledge. Somebody had to put it together for a very high intelligence level. So we went over this once before in this same type of presentation, but we need it now for what we're going to go over in the eye. Okay. Now, I was trying to think how to do this. Draw this guy over here, and then some room here and some room there. Okay. Now, draw a line here, and a line here. And this is going to need for radial, by the way. So we're 0 here, we're going to put a point there. No. We're here, per point.
You just need a radio
90
distance.
degrees per point. Now, we're coming down the other side. Come down. You see what we're making? A sine wave.
Okay.
That mathematics makes a sine wave. Okay? Now, if you come down here, it's going to come below the line. Okay? Now, what's the parameters of a sine wave? 1, 2, height, right, in the middle. Now, draw the sign. Fill in the dots. Everything in our world depends on that sine wave. So because we're just starting into this whole concept, we're going to start with the visible spectrum. Okay, that's not where it starts. Under the visible spectrum comes the radio spectrum. All astronomy, almost now, is done radio, not done anymore with your eyeballs. So those of us who are going to follow will have to learn radio. Okay? So when I talk about that sine wave, it doesn't matter if it's a radio sine wave, or an X-ray sine wave, or a visible sine wave. They're all the same. Okay? So what we want to do with that sine wave, okay, is we want to do something with it. Or somebody's going to do it for us. We're going to modulate it. M-O-modulate. Modulate, demodulate. We're going to change it. So the first way to change it is change the amplitude, how high it is. You see that when you're talking to, you see the thing on TV go up and down. The louder you are, the higher you are, goes up, goes down, so it's modulation. You've got to change it from this to something else. Okay? So, or you can change the frequency. In other words, if it's this here, I can make it do different things like this. So if I've got in front of one of these funny mirrors where you're fat here and skinny up here,
Yeah.
they're changing that wavelength. Okay? So basically all these terms you have to learn. Then the next one that kicks in after that, we change the amplitude or the frequency. So that's what AM radio is, amplitude modulated. FM radio in your car, you got both, but AM or FM. FM is frequency modulation. Okay? Then there's other ways to modulate it. You can modulate what we call the phase. I was trying to think how to do this. Now, you have a different color? Okay. I'll make another one of these here under here then. But instead of going there, start here. Oh, don't start. I'm sorry, start here.
Like that?
You know, but you better run your lines. You know, this is wait. Let's see what it is. This is your baseline. Okay. So instead of starting on 0 or the middle, no, we're going to start up here. Okay. So instead of starting here, we're going to start up here. Or we're going to start here. So they have to be what we call out of phase. If you put them on top of each other, they're not going to match. You want that. Okay. Yeah, good. Now put a line down here. Okay? That's good. next one. Now, you can see those are out of phase. If you put one on top of the other, they'll no longer, this guy here, they will not reach their peak at the same time. That's what quantization is, basically. I mean, the Q on the radio. So, in our case, what we're going to work on is the next thing we're leading up to. So, we'll turn the page again. Okay. On the electromagnetic spectrum, it's RGB. RGB, red, green, blue. Now this you got to get if you can. Red, green, blue. Okay? All color with your eye is depending on RGB. Red, green, blue. Okay? So that's the electromagnetic spectrum. Red is here, blue is up there. So below red we have radio. Below red radio we have sound. So we'll be going down as we talk about this. From visible spectrum, because we all see, it's easy to understand. Radio waves are invisible, not so easy. And then as you go up, we go up into the ultraviolet, cosmic, and X-ray. Most of you know that probably have had an X-ray sometime. So basically I'm up there, but this is what the eye sees. So write down 4 for red, 440. I tell everybody to get this 440 in your head, because as you go through stems, it's going to start making sense. 440 at sound is A5 on the piano. All musicians that you're going to play music with or hear are going to tune to that. 440. That's sound. That's 440 hertz. H3. Then as you move up into radio world, if you get your first license,